So we're going to talk about cholinergic transmission, which is referring to acetylcholine. Now, remember, from the first step of neurotransmission, we need to make neurotransmitters. So we need to make acetylcholine, and that's going to require acetyl-CoA and choline. And there is an enzyme that takes these two and forms acetylcholine, and the enzyme that's responsible for that is called choline acetyltransferase. This is a synthetic enzyme that you need to make acetylcholine. Now that you have acetylcholine synthesized, remember you have to store the acetylcholine into a vesicle, and that is going to occur via a transporter, and that transporter is called vesicular acetylcholine transporter. Now that the acetylcholine is in the vesicle, we need to release it through a calcium-dependent process, and when the action potential reaches the nerve terminal and opens up the voltage-gated calcium channels on the nerve terminal, calcium influx triggers the fusion of the vesicular membrane and the nerve terminal membrane, and you end up with acetylcholine released into the junction. Once the acetylcholine is there, it needs to bind to a receptor, and there are two major types of receptors for acetylcholine. One type is a GPCR, and those receptors are called muscarinic receptors, which there are subtypes, most important being M2 and M3, which are coupled to GI and GQ respectively. Acetylcholine also can bind to ligand-gated mixed cation channels, and these are nicotinic cholinergic receptors. And there are subtypes as well found on skeletal muscle, which we call N for nicotinic, subscript M for skeletal muscle, and N for nicotinic again, subscript N for neuron. Now that we have the acetylcholine binding to its receptor, depending on where it is and which receptor it is, you're going to get your biological effect. And now we need to terminate the signal. And the way that is accomplished for acetylcholine is through enzymatic degradation. And so we have acetylcholine broken down, hydrolyzed to choline and acetate via the enzyme acetylcholine esterase, which is in the junction. The choline can be taken up through a transport mechanism into the nerve terminal, where it can then be reused and resupply the choline to make more acetylcholine. And this transporter is the choline transporter, which we can call CHT, and that is found on the nerve terminal. So to summarize the steps for cholinergic transmission, we have our synthesis step, which is going to require the enzyme choline acetyltransferase. We have the second step, which is storage, which is going to require the transporter VACHT. We have vesicle fusion with the nerve terminal membrane and exocytosis, and that's a calcium dependent process. Number 4 is binding to the receptors. So we have receptor binding, which we have either muscarinic receptors, which are GPCRs, or nicotinic, which are ligand-gated cation channels. And number 5, we have enzymatic degradation by acetylcholine esterase. Now, we could also include the choline transporter that's required to take up choline, which provides the choline for synthesis of acetylcholine.